This is chapter 7. We're going to be talking about the last control structure in C++, which is the repetition structure, or sometimes called loops. Our objectives for the chapter is you'll be able to tell what's the difference between a pretest and a post-test loop. We are going to look at pretest loop and both the pretest and the post-test loop using pseudocode and flowcharts. In C++, we have the while loop and the for loop, which are pretest loops. We'll look at those. And then we're going to see how to use counters and accumulators in your loops. So the repetition structure, or sometimes called loops, processes one or more instructions repeatedly. So if you start writing a program and you repeat instructions more than once, then you should change that into a loop. Every loop contains a Boolean condition that controls whether the instructions are repeated. This is just like the if statement. So the loops are going to have a condition, just like the example where we had about the password. And the condition would be if the password is incorrect, then keep looping, keep asking them for the password. Or if it's incorrect and they've tried it 3 times, keep looping. So the looping condition says whether to continue looping through the instructions or not. And you always want to check, if it's true, then it's going to go into the loop. If you look at the slides that you printed, there are many more slides than what I'm going to show you here. What I've done is just included everything that has what I'm going to talk about, but I'm just going to show you with examples, and the examples are in the slides too. So here's a problem, and the problem is that we want to create a program where the user enters the commission for many different salespeople in a company, and the program prints out, well, they enter the commission and also it calculates the commission, and they're going to enter the commission rate and the sales amount. So the first example here is just something without a loop, and this is going to just ask for one person's commission rate and one person's sales amount. So we ask for the sales, and actually we're not going to ask for the commission rate. The commission rate is 20% for everybody, so this is a constant, the commission rate, and it just calculates the commission by multiplying the rate and displays the commission. Now, if we don't want to keep rerunning the program and we just want it to keep looping and asking us for the next salesperson, we could do something like this example 2 here, this algorithm 2, which I have a little bit closer here in this slide. So algorithm 2 with a loop. At the very start, we ask the user to enter the sales amount. This is called a priming read. Priming read means that we read the value that we're going to be comparing here in the loop, and then we have to update that value inside the loop. So this is where we update this read statement. So we have a priming read, enter the sales amount. We're going to repeat this loop if the sales amount is not equal to a -1. So the -1 is a number that they have chosen to make the loop stop. It's a value that they know that's not going to be a valid sales amount. And so it could have been -10, just whatever you tell the user to enter. So you could tell the user, keep entering sales amount. If you want to stop the program, enter a -1. That's what's going to make it stop. This condition has to be true for the loop to go inside. Inside the loop, we calculate the commission, we display the commission, and then we have that updated read. We need to ask again for the sales amount, And the reason we do that is because this, when you're here, it goes back up to this line. It doesn't go back up here. So from here, it goes back here to check. And it will keep doing this until this is false. Once this is false, I'm sorry, right, once it's false. So once this is not true, then it's going to exit the loop. Here's your loop body. And let's go ahead and do what we're going to do is we're going to go ahead and look at this actually coded, okay? And we're going to code it using a while statement. So the while statement is the statement, one of the loop statements that we use in C++. While is going to be a reserved word. The condition, just like in the if statements, will go next to it in parentheses. Just like with the if statement, if you have one statement, you don't have to put the curly braces, but if you have multiple statements for the while loop, you'll have to use the curly braces. Just like in the if statement, your condition here can contain constants, variables, functions, arithmetic operators, comparison operators, and logical operators. Okay. Let's see here, we'll stop for a minute. Go back to there. Okay, so let's just code this example here. So it says to enter the sales amount. So I'm going to have a variable for sales, and it has to be double because you can sell $1,000.50. So it's got to be, it has to be a double. So we're going to ask the user. The first thing that we're going to do is ask him to enter the sales amount. CN to sales. Okay, now we want to do the repeat statement, the while loop. So the while loop is while, notice it turned blue, so while is a reserved word, open parentheses, sales is not equal to -1. And here we could say enter the sales amount, -1 to stop. How about that? Okay, so while the sales amount is not equal to -1, our loop will keep going. I'm going to need 2 curly braces, right, because I have multiple lines inside my loop body. First is to calculate the commission, so I'm going to need another double, and this is going to be for commission. Initialize it to 0. Commission is equal to sales. Now I can put times 0.20 like this, or what I'd rather do is I'd rather make commission a constant. And the reason I'm going to make it a constant is because in most companies commissions is constant, and it doesn't change every day. Commission will increase, but it's not a daily thing. It could be yearly or every 5 years or something like that. So here I'll put commission rate. And commission rate, just as a review, we start with the word constant, the data type, the name of our constant. We use capital letters, not because we have to, not because the program's not going to run, but because it allows us when we do this, it allows programmers that read our code to know that commission rate is a constant when it's capital letter. So we're just following a format of writing. So we've done this part. Now we're going to display the commission, see out. The commission is, or whatever, however you want to say it, and commission. Then it says I have to ask for the sales amount again. So I'm just going to copy this code here and place it here. This is my end repeat and while, sorry. Now once it exits, once I press -1, it exits, it goes here, and there's nothing to do here. But I'm just gonna say done, just because I want you to see that it goes to this line here. And every time it prints this, the commission is and the commission amount, I do want it to print a new line, so I'm going to put a new line here. So this is ENDL for new line. So it says enter the sales amount, -1 to stop. So I'm going to enter $1,000. I sold $1,000. So for $1,000, I get $200 commission, and then it asks me again to enter a sales amount. So I'm going to enter $2,000. My commission is $400. Again, I want to make sure that my calculations are correct. So before I even test my program, I've written down some sales amount, used my calculator, make sure that these are correct. So now I'm going to test my loop to make sure that it stops. So -1 to stop. When it stops, it exits and it prints done. Okay, so this is the while loop. This is what we call a pretest loop. So the loop tests the condition here, and then if it's true, it goes inside. This is a pretest loop. Again, this here is what we call the priming read, and here it's the updated read. We have to update it because we're never going to go back to these two lines. The program never goes back up here until you just start over again. Here's some other examples of while statements. In this particular case, we're just asking for an age, and if the age is greater than 0, we display it. If not, if the age is not greater than 0, then we exit. Here's another example. Here we're asking a yes or no answer, and we're going to keep looping if the answer is yes. So here's our priming read. Here's our updated read. If they enter no, we go back up here. We check, did they enter no? Did they enter yes? And it would be false. It did not enter yes. So boom, it would exit. So next thing we're going to look at is how to use counters and accumulators in these while loops. Sometimes problems require you to calculate a total or an average. Something easy that you can relate to is an average, like for your grades. So you have some test grades, you're going to add them up. So you accumulate all those, you add them up, and then you divide them by the number of test grades, and you get the average. So to do this, we're going to use two things. One is a counter to count how many test grades you've entered. if we don't know exactly how many there are, and an accumulator to accumulate those test grades. So we know what the total of all the test grades is. There are two tasks that are associated with counters and accumulators. One is initializing and one is updating. So let's look at that. Initializing and updating. So here's some examples of some counters. So we have years here. We're counting the number of years, increasing by 1. Even number, decreasing by 2. So our counters can increase. They can increase by 1, they can increase by 2, by 3, however you want to increase by. And here we can also decrease our counters. So counters can go up and down by a constant, literal constant value. Accumulators will have the variable that you have on the left-hand side has to be repeated to accumulate. So sum equals sum plus number. And if you have this in a loop, it just keeps adding to the variable sum plus number. Assign it back to sum. Now you have a new sum plus number, and it just keeps accumulating. We can use the shortcut that we learned before, which is putting together the plus and the equal sign like this. So these are the same thing. This says years equals years plus 1. Even number equals even number minus 2. Loops can be controlled using a counter rather than a sentinel value. The sentinel value was that -1 that we saw earlier. So we stopped it with the -1. So we can use a counter. So we can say, the person enters something, and we can say, okay, when you get to 10, stop. So that would be a counter control loop. All right, before we go to the counter control loop, there's something here that was really important. There are two tasks associated with counters and accumulators. One is initializing and one is updating. So let me see. I want to show you what that is saying with counters. Let's go over here. We have our sales, our commissions. So let's say that here's that sentinel value. So this while loop is stopping with a sentinel. It's not a counter. It can go 10 times, it can loop 5 times, however you want. Sometimes you want to loop to just loop 5 times, only loop 3 times. But for this one, I think what I want to do is I'm going to go ahead and just accumulate the sales amount for fun. Okay, so I'm going to create a double here that's called total sales. And because this is an accumulator, I have to initialize it. Now, if I don't initialize sales here, it's not the end of the world. It will give me a warning, but as soon as I enter the sales amount here, it overrides whatever junk is inside the memory location. So if you don't initialize values, it just contains what we say junk data, and that can be a problem for accumulators, because you want to start counting at 0 and accumulating at 0. So here I would enter the sales amount. So here at the top, I'm going to accumulate total sales. Say total sales equals total sales plus sales. Now the reason I put it here at the top is because this sales amount counts, right? So if I enter 1,000, I want to accumulate that 1,000, and then the next time I enter my second one, let's say I enter 2,000, I want to also accumulate the 2,000. So if I put it here at the bottom, it does not add this first sales amount. So this here is the accumulator. And, you know, let's just print that out and see what it looks like. So it just accumulates my total sales. So notice here in quotes, again, this is just a string. I can type it any way I want, but here is my variable. It has to look exactly like that one. So let's say I have $1,000 that I made, and then 2,000, and then I'm going to stop. Okay. So 1,000 plus 2,000 is 3,000. I did not put an end line here, so it's kind of hard to read. Let's run it again. 1,000, 2,000, and -1. So total sales is 3,000, and then done. So this is an accumulator. And so what's important with accumulators, we said, is that they have to be initialized and updated. Here's my initialization, and here's my update right here. Okay, that's where I accumulate. Okay, so let's go back to this particular slide. This is looking at a flowchart with a loop. And I just wanted to show you what it looks like to flowchart with a loop. Looks just like your if statement because you have a diamond here. So diamonds are always used for conditions. Now the only way you know this is a loop is that if this condition is true, there's a line here that keeps going up, and this is what tells you to repeat this condition. Is it true? Yes. Okay, keep going up like this. Now in this example, we have a pretest loop that is controlled by a counter. So this loop is asking, this program is going to ask for, oh, it's not asking for anything, it's just going to count the days. And it's going to start counting at 1, and it's going to stop counting at 5. So this loop is going to repeat 5 times, from 1 to less than 6, which is 5. The counter is right here. The counter is counting increasing number of days by 1. They also have an accumulator, a price accumulator. Add price to total price. So it keeps accumulating this price that they entered. So my counter is initialized, my accumulator is initialized. I'm gonna check to see if number of days is less than 6. Right now it's a 1, so it is less than 6. We go to the right, the true path. We ask the user to enter the price. We increase the number of days by 1, so now we're at day 2, and we accumulate price. Go back up. Number of days is a 2. Is 2 less than 6? Yes. Go to the right, enter the price, increase the days to 3. Accumulate price. Go back up. Is number of days, which is 3 now, less than 6? It is. Here we increase to 4. Is 4 less than 6? Yes. Increase to 5. Is 5 less than 6? Yes. Increase to 6. Check again. Is 6 less than 6? No, that's false. Now that it's false, we're going to exit the loop, and it's going to calculate the average price. So it does some calculation. It takes the accumulator here, the total price, divides it by number of days. So total price divided by Remember, number of days at this point is a 6, but we only entered prices for 5 days, so they had to subtract 1 from that to make this a 5, and then they displayed the average price. So it looks like this was a stock, and they wanted, it's a stock price here, so this was a stock price. They were accumulating the stock price for 5 days, and they gave you the average in those 5 days of the stock price. Okay, the next statement that we're going to look at, the next loop statement, is called the for statement. And it's also a pretest loop. It's commonly used to code counter control pretest loops. So the counter would be something like this. So this here, we're using a while loop. We can do the same thing with the for loop. Commonly used to code counter control loop, pretest loops, more compact. They're easier to read, I think. So this is some examples of some for statements. Let's start here with this first example. This first example displays the numbers 1, 2, 3 on separate lines on the screen. So for is going to be your keyword. You have parentheses. And then this for loop only has one statement. So this will iterate and just do this one statement. So we don't need the open curly braces. So the way this loop works is like this. This is your initializer. This is going to be your counter. You define the counter here. You can only use this X in this loop because it's defined in the loop. You initialize it to 1. The loop will first, the program will first test to see if X is less than 4. So is 1 less than 4? Yes. Since it is, it will go here to the cout statement. It doesn't go here yet. It goes here to the cout statement, and it outputs a 1. When it outputs a 1, when it goes back up to the loop, what it does is it goes to this statement first, and it increases to 1. Then it checks to see if it's less than 4. 2 is less than 4, so we cout 2. Then it goes back here and it increments to 3. Is 3 less than 4? Yes, so it outputs 3. Goes back here, increments to 4. Is 4 less than 4? No. So it stops. The loop stops. This is the same thing, except it's going backwards. It's starting at 3 and stopping at 1. Notice I've also added the open and curly braces. It's not necessary. You don't have to have these because you only have one statement, but you can have them. It's fine if you have them. Now you do need those open and curly braces if you have more than one statement inside the for loop. So this here, it's what I just went over on what happens first. First initializes, it then compares, it then couts, it then increments, compares, cout, increment, compare, cout, like that. Okay, and also remembering that, oh goodness, sorry about that. Like I said earlier, when you initialize and define, when you define this variable here, int x equals 1, you can't use this x anywhere else in your program because it's only available to you in this section of code. So let's take our commission program and let's say that I knew specifically that I only have 5 people working for me. So I'm going to change this. And I'm going to say for int x equals 1, x is less than or equal to 5, because I know I have exactly 5 people. or I could say less than 6. Okay, so they did x plus equals 1, like this. I also wanted to show you something. I don't know if it's in your book, but there's also a shortcut where you say x plus plus. This increments by 1. That's where the C++ comes from. So x plus plus increments by 1. I'm going to go ahead and just leave it like you have it in your book, because right now it really makes sense that's incrementing by 1, but you'll see me using that often. So we have the for loop. Initialize it to 1. Is 1 less than or equal to 5? Yes. So I'm going to ask for my input here. I'm going to ask the user to enter the sales amount. Okay, enter the sales amount. We're not asking them to stop with a -1, so I'm going to take that out. And then I'm going to accumulate. I'm going to calculate commission. I'm going to see out the commission and end the for loop. So this is going to ask me 5 times. So this is if I know specifically how many times I want to iterate. So sales amount 1,000, sales amount 2,000, $3,450, $345, $100. Okay, so it asked me 1, 2, 3, 4, 5 times, and then it says total sales was $6,895. So my people made $6,895 in the 5 days, and then we're done. So this is your for loop, and again, it's you just want to use it when you know exactly how many times you're going to iterate. Now, you can replace this 5 here with a variable. Num how about just salespeople? So let's say that I ask 0, this is an integer, and I ask like see out how many sales people will you be entering? Something like that. I don't like that question, but that's good for now. And then salespeople. Something like how many salespeople work for you, or how many employees do you have, or something like that. So if they enter 2, then this loop will iterate 2 times. If they enter 3, this loop will iterate 3 times. So it's still a specific number of times. It's just dependent on what you enter here. So if I just say 3, then I only get asked 3 times, and it stops at 3. And again, here I can put salespeople. I can do a calculation. There's multiple things that I can do here. I can put a constant. So that's my for statement. This is just more examples of for statements that you can look at. Another example, this one calculates and displays the sum of 3 even integers. So here, I think they wanted you to see, oops, how how to fix the like this particular program has an error and they want you to see the incorrect and the correct code. So this is the incorrect code using the for statement. So what they did is they calculate and display the sum of 3 even integers. So they have a for loop from 1 to less than 4. So this loop iterates exactly 3 times. But inside the loop, they're checking to see if the user entered valid data. So when they ask them to enter even integer, if they entered a 4% to the way that modulus works is that it divides 4 divided by 2. It doesn't have a remainder. Remainder is 0, so it's even. But if you have 5 modulus 2, remainder is 1, so it's not an not an even number if you enter 5. So the problem here is that if it's not an even number, then this only iterates 3 times. So you're not going to have the sum of 3 even integers. So if you waste basically a loop, an iteration, if it's not an even number. So what happens is, let's say here in this output, if you enter a 7, it's not even, so it asks you to enter another one. You enter a 4, and now you only had 2 even numbers, so it gives you the sum of 8 plus 4 is 12, but that's not 3 even numbers, right? It says the sum of 3 even numbers. So the way that we can change that is by using a while loop and having a counter. And so what we're going to say is, while x is less than 4, so we want to count, and we only want to count if it's an even number. So you have here, if it's an even number, go ahead and increment x to 1. So this here will now actually iterate. It can iterate many times. Like if I enter 4 odd numbers and 3 even, it iterates 7 times. So it iterates until I get exactly 3 even numbers, even if they enter 10 incorrect numbers. Okay. That's the output. And that's the end of this chapter. In the next chapter, we're going to look at one more loop structure. So in this chapter, we looked at the while loop and we looked at the for loop. And in your labs, you'll be using both of those, implementing those.